So I hope everybody is able to see my screen. If there is any issues, just let me know. Today, I'm going to take you through DevOps fundamentals. My name is Silva. I have an experience of 9 years in IT industry. And today, I'll be your instructor or mentor who will take you through DevOps fundamentals. I also have experience of 5 years into DevOps. I used various tools, implemented various CI/CD pipelines in different products. And I'm just here to share you some of the experiences along with the DevOps process. So let's begin. If I'm not audible, if I'm going a little bit faster, just let me know, because I'm going to use a lot of new words here into DevOps words. So I want you to understand everything clearly. There is any problem in understanding, stop me right there and throw me your queries. I'll be happy to address it. Fine. So let's go to the first topic. What is DevOps? So there has been so many definitions given for DevOps. There is no single definition which says or which defines DevOps strategies. But there are some accepted definitions. I'm going to tell you one of that. So DevOps says that an operational team and development team should work together, collaborate together from the start of your product's lifecycle, then through the development process and to the production support. Which means that as a developer or as a operation guy, I should know end to end what is happening in a product. So DevOps says that a development guy and operation guy should work together, achieve a common goal. So DevOps is more about process or culture or practice rather than just tools. So let's be very clear. In current trend, what happens is that people think knowing some 7 to 10 tools makes a DevOps engineer. It's not so. To be a DevOps engineer, you should actually have a cultural shift. So let's see what are those cultural shifts, what are the practices that is required to be a good DevOps engineer. So I have been telling DevOps, right? So what is DevOps? How this word was coined? A developer is a development is one part of the product cycle. The other part of the product cycle is operations. So we combine both terms as DevOps. So what does a dev do? A dev usually codes. His work is nothing but he gets all the requirement gathered from your Scrum Master, his lead, or the organization himself, or the client. Okay, he gets all the requirements. He does a design for that particular requirement. It could even be a project, or small application. Then he starts coding on it. He can do coding in any languages, and he has a different environment which is called as a developer environment. So once development is done, that environment is over. Fine. So developer doesn't go to the ops side. So what does the ops guy do? Ops guy provides infrastructure for the developer to carry on his work. An ops guy actually deploys the product. An ops guy is responsible for making sure that the product is up and running. He is also one of the person who takes care of your database structures, which means that ops guy doesn't know what you have developed. He's a person who just gives you the environment to develop your code. So what happens in today's scenario is that a developer and the ops doesn't talk to each other. They work in silos, which means that they work in their own environment, not knowing what to do between each other. So this is just to tell you how the word DevOps has been coined. So to tell you again, Dev is one environment, Ops is another environment. Both together we call it as DevOps. So why DevOps? We saw what is DevOps. I told you that DevOps is a process. But why do we need to go to DevOps? There are so many models, right, in industry, like your waterfall model, your agile. So why people go crazy when someone says DevOps? So there are some 4 important metrics to that. The first thing is deliver faster. When I say deliver faster, it directly implies to the fact that I'm able to deploy my product in a high frequency. For example, take an example. I write a piece of code. In today's traditional environment, what happens is that for a piece of code, a single piece of code, to get into the deployment environment or a delivery environment, it takes almost 2-3 months. But when you do the same piece of code in the DevOps process, it goes in an hour or in a day. It depends on your company strategy. Okay, so that's what the second point says. Deploy more frequently, which means that I get the freedom to deploy my code as frequently as possible and as much faster as possible. Okay. Third thing is failless. So what does this failless a developer writes a code, then it gets shipped, it goes to the customer side, and then a customer raises a bug, it comes back to the support team then goes to the development team. Actually, this entire cycle almost takes 2 to 3 hours. Fine, 2 to 3 hours. Some in some cases it takes 3 months also. Okay. When you take DevOps, because we are sending a small chunk of delivery objects to the production line, the possibility of failure is very less, and inversely it also improves the recovery rate. And DevOps also brings in the feasibility of having a high performance system. Okay, we saw if you have any doubts till this point, let me know. I shall address it, and then I'll proceed to the levels of DevOps, because it is very important to understand each jargon that they use. Only when you understand, you will be able to understand going forward. So if any doubts you have, just stop me then and there and ask me doubts. Otherwise, I'll just proceed to the next level. I'll just assume that you will understood, and then I'll proceed. So let me know if you have to wait. Fine. I assume there are no queries. Let's move on to the next thing. So as I said, there is no standard strategy defined for DevOps. Each company has their own strategy, because DevOps is more of a cultural change or a process change. But there are some best strategies which you are supposed to follow in order to have a successful DevOps pipeline. So we'll see all those best things now. So first thing is the values, then principles, methods, practices, and tools. So we'll start from values. See, what are those values? So there are 4 important core values, which in short we call it as CAMS. C stands for culture, which we are always talking about DevOps in DevOps. A stands for automation. M stands for metrics or measurement. S stands for sharing. So culture, as I said, what is the culture? See, when you take DevOps, the important thing everyone talks about is the collaboration between your developer and operations. Culture is, today what people think is that culture means going out for a project party or spending time together as a team. So that doesn't make actually bring proper culture into the team. The culture here means that understanding the developer environment and understanding the ops environment. So as a developer, I should understand what ops guy is doing. As a ops guy, I should understand what a developer is doing. So only then there is actually a cultural shift, which means that I value ops guy efforts, and ops guy values the developer effort. And most importantly, both the developer and the ops should understand the organization goal, and they should have a common mindset to work towards that goal. So the culture aspect is the first aspect, which is most important in DevOps, which should bring both Dev and the ops together. And the next comes your, so there is a famous saying, Patrice DuBois says, he says that culture cannot be brought to technology. Culture is more of a mindset shift. Okay, so Patrice DuBois is called as the father of DevOps. He's been part of, he has written many books, and has defined many strategies. So we have picked some of the strategies which has defined, and I'm going to throw you all those things in the upcoming session. So I said again, first thing that comes as part of DevOps is the cultural shift. And see, as I told you, development team works in a different environment, operation team works in a different environment. They have built a wall between them in current scenarios, or in today's traditional method of software development. A developer doesn't talk to ops guy, and ops guy doesn't talk to a development. Otherwise, they talk in a different language which nobody understands, right? So in order to bring up this or break up this wall, we tell people to adapt to DevOps. Now next is automation. There is a assumption. Whenever people say automation, people think that, whenever people say DevOps, people think that I have to just go and automate everything. It's not the case. See, automation is a important point in DevOps, which says that you will have to eliminate your daily routine task. For example, say there is a product. Okay, I'm doing a build for the product. In order to say the status of the build, today what happens is that a person is there who will log into the build environment. He'll collect the build logs. He'll see if it is successful or failed. If it is a failure, he'll collect the failure logs. He'll actually collect. He'll identify the errors. Then he'll go and find the person or the developer who has delivered the piece of code which has actually failed the build. Then he has to mail the developer saying that your piece of code has failed today's build. Okay, this is what is happening today. Now see the turnaround time. Imagine the build takes some 2 hours to complete. It will take another 2 hours for the person to actually go through the build logs, identify the issue, and mail it to the developer. Now again, the developer see the mail, he has to respond, and for that it will take another 2-3 hours. Okay, so what we are saying is that checking these logs is a routine process. So why do you have to do it manually? Write a simple tool, write a simple script which can actually parse your log file, then make an automated mailer which will send only the errors to the person who has actually delivered the code. So we have to actually think and decide where to implement automation. Just because we can do automation, we are not supposed to automate everything in the system. We should know where to put what. So that's what DevOps says. Automation is more important, and you should also know where to put what. Okay, next is metrics or measurement. Fine, you have defined a culture in your organization. You automated so many things, but how do you measure what you automated? For example, now I told you, right? If someone manually sits and sends a mail for a build failure, it takes 2 to 4 hours. But when I do an automation for that, it only takes 2 minutes for me. So here the metrics is that I improved my build time or the turnaround time. Yearly, which took 3 hours, now it only takes 2 minutes. So these kind of metrics and measurements are important to identify the benefit of automation and then take it to the next level. So once you do automation, it is also important that you spend your time in collecting the metrics and then sharing it to the right audience. Fine, sharing next. So as I said, right, the organization goal is the important factor that should stay between the dev guy and the ops guy. Okay. So when I say organization goal is important, it is also important that knowledge sharing takes place. For example, as a developer, I know how to do a build, but as an ops guy, he may not know how to do a build. But it is the responsibility of a developer to give a KT or share this knowledge on build to the ops guy. So whenever you do this knowledge sharing, it improves your complete environment. The environment becomes more less coupled, and it will be more interactive, and it brings up new ideas. When there are new ideas, it automatically elevates your product, and it also gives the freedom to develop faster. And one more important thing is that when you start sharing your ideas, it eliminates the duplicate efforts. For example, there could be 2 different teams working on 2 different products. Okay, but there can be a scenario where a single tool can address problems in 2 environments. Okay, DevOps says that do not waste efforts or do not reinvent the wheel, which means that a team which has written a piece of tool that will address problems in both environments should be reused. So a knowledge sharing could help address this problem. Okay, we saw what are the core values on DevOps. Now we'll move to the second thing, the 3 ways, which is called as the DevOps principle. Okay, there are 3 different principles which is defined. First one is system thinking, then your feedback loops, third one is your continuous experimentation or learning. So I told you, right, be it a developer or be it ops guy, I should first understand the architecture of the system or the complete project structure. Only then I will know the end-to-end structure of the product, and I can address the issues at any cost. So system thinking is very, very important. Feedback loop. Okay, what is the feedback loop? I'm developing a product. I run my piece of code. I did testing also, but suddenly my product fails in the operation environment. Okay, which means that the operation guy will come again come back to me again saying that boss, your piece of code has failed, fix it up. Okay. DevOps says that do not let such things happen in your environment. As a developer, I should own the responsibility of giving a feedback to myself. For example, I write a piece of code, I should test it completely. Okay, so this testing can happen in two ways. One is that the testing can improve the quality of my product, or testing can allow me to give input to some other product. So a feedback loop is very important to eliminate your issues in the production. Next comes your continuous experimentation and learning. Okay, I have been keep telling that both your developer and your operation guy should be in sync, right? So how will we be in sync? Both should be knowing each other environment properly, right? So this point says that there should be a continuous learning, which means that even if a developer guy, I should have the urge to learn what is happening in the operation side. Even if an operation guy should have the urge to learn what is happening in the developer side. Okay, so only when they have the urge to learn, the system understanding or system thinking becomes better. And then there is another point saying continuous experimentation. So what does that mean? See, as I told, DevOps is a process, and DevOps can be achieved through implementing a lot of tools in outside market. Today, if you take a DevOps tool, or if you just Google the current DevOps tool, you'll get hundreds of tools. Okay, but how will I know which tool fits into my product, or how will I know which tool can make my job easier? So there should be a continuous implementation. An environment should be given, or you should create an environment where your developer as well as your operation guy is able to do a POC, and then make sure that if that tool is implemented in the process or in the project, is things become very easy to go. So these are the main three DevOps principles that is called as the three ways. So I'll just pause a bit here. I want someone to talk and let me know if there is any doubts. Am I going too fast? You can just tell me. I'll stop and go slowly. If I'm not able to understand any jargons, let me know. I'll just explain them again. I'll wait for a minute. Fine. Okay, I got some questions. Selva, please slow down. And there is a thing saying, can you recap levels of DevOps? Sure, I'll just recap what are the levels of DevOps. I'll go back. Okay, so I have defined, or some experts have defined DevOps into 5 levels: values, principles, methods, practices, and tools. So I have explained 2 levels now: values and principles. So these are just 5 levels. Just given you the agenda. Explanation is there in the upcoming slides, where I explained you the values. The core values is called as CAMS in short. Culture comes first, then your automation, metrics, measurement, and sharing. So there was a question saying, what is automation? So see, the name automation suggests that it runs on its own. I don't have to manually go and say trigger something or manually copy paste something. It means that there's no intervention that is required manually. Okay, it runs on its own. I just schedule a job, it runs on its own, it takes care of everything from end to end, and then gives me some output. That is called as automation. Okay, automation is more important to order to eliminate the routine process. When you automate something, the benefit is that there is a less possibility of human errors, because in today's scenario, only human errors bring up a lot of issues in the deployment or the customer side. Okay, to not eliminate that, we do go for automation. So I think those are 2 questions that was shared privately with me, and apart from there's nothing. So I'll go to the next one, which is methods. The next value of DevOps is methods. I mentioned something here, right? People, process, tools is the first thing. Next is continuous delivery, lean management, change control, infrastructure code. We'll see one by one what are they. Okay. People over process over tools. So how do we read that? Is people over process over tools. Okay. Today what happens is that in certain organization, what people do is that as soon as they hear the word DevOps, they go and buy some Python tools. Okay, they buy these tools, and what they do is that they ask the engineers to implement this tool in their process. Do you think it is this to be a proper idea? No. What says is that first identify people. DevOps should identify proper people to do proper tasks. For example, the first thing is to do to create a team which is capable of doing the process that you are going to define. So first identify the people. So people comes first, then process, then define your process end to end from your source code checking to deployment. What is the process that you are going to follow? Define that. Then go and search the market for tools. Okay, identify which tool can actually ease up your process. So this is the order of flow which DevOps is suggesting. This is very important, because if you just buy some tool and try to implement in your product, it's gonna bomb your product. Instead of making your product very easy, you'll end up bringing up new bottlenecks. So it is always very important to identify the process. Then for the process, identify the tool. Fine, this is first thing. So next is your continuous delivery. So what is continuous delivery? I've been keep on telling development team, right? So what does the development team do? They just code. They keep coding on the requirement and they push it to some repository. Repository is your source control repository. Okay. Once they push the code, it goes for build. After build and testing, it will be delivered to your customer on the local environment. So continuous delivery is a practice of coding, testing, and releasing software frequently, as fast as possible, as frequently as possible in small batches. So for example, there could be a requirement which will take 2 months of time. Okay. But as a developer, I should split logically so that I'm able to do a small amount of delivery every single day for the 2 months. Okay. So that is what continuous delivery says. So what are the benefits of continuous delivery? I've given some stats roughly. This is taken from DZone. So which says that a team which is doing continuous delivery actually spends 22% less time and effort in unplanned work. Okay, what are these unplanned work? I told you, right, whenever I want to code, I want to design something, I get some requirement. Fine. It is not necessary that that requirement stays the same until the product is delivered. There could be a sudden change in the requirement, a sudden change in the design. Okay. In those cases, DevOps gives me the free DevOps. When we follow DevOps process, I'm able to spend I'm just spending 22% of time now to incur the unplanned work or incur the ad hoc activities. And then the second statistic says that changes to the products has only 3% of failure rate. So see the benefit. As I told you, right? If you don't follow DevOps, if you just keep your code for 2 months, then directly put into the testing, you are wasting actually your 2 months of effort. But if you deploy code every single day and deliver to the testing time, the failure becomes very less. So DevOps says that if you do this continuous delivery, the failure is only 3%, which is very much required in our today's development, faster development. And then third thing stages, teams recover 25% faster from failures. Okay, what does this point? The point 2 and 3 are actually interconnected. Say for example, as per DevOps policy, if I fail, the entire team fails. For example, if I introduce a bug in the product, the entire team fails. Okay. So what I'm supposed to do? I'm supposed to make sure that the failure is less. That is what DevOps says. If you do continuous delivery, the failure is less, and it is very easy for you to recover fast. For example, I do a 100 commit in order to ship my product from development side to delivery side. Okay, there could be 1 or 2 commits which has failed, which has introduced a bug. It is easy for me to remove those 2 commits easily. Okay, imagine if you do that if you take 2 months, 3 months to deliver your complete changes, and then deliver one single commit and deliver it to the production. What happens is you won't be able to identify which commit has given you the failure. So DevOps continuous delivery addresses all those issues. Next is your lean management. So as I already said, always do work in small batches. So make sure that work actually goes to your build and then passes your testing, then it goes to your delivery environment. Work in progress limits. So make sure that you have a limited work or limited module split up into chunks and deliver it in the batches. Feedback loop we already saw. The fourth jargon is new, which is visualization. So this brings to the point of measuring your improvements or measuring your DevOps, where you create cool charts through there are a lot of tools which I will be telling you going forward. So using that, we'll create cool charts to tell people that my 3 hours of work which was spent because of manual effort is being reduced to 2 minutes after doing an automation. So all these things are there in lead management. Then we go to the change control. So how well are we able to control the changes that goes to your delivery pipeline? Okay, there are 4 important points here. Eliminate fragile artifacts. What are artifacts? Artifacts are the end product. Your end product. It could be your binary. It could be your chart file. It could be your documentation. Okay. DevOps says that eliminate fragile artifacts because they when you build a DevOps pipeline or when you build a DevOps chain or when I say it is a value chain. Okay, the chain breaks where there is a fragile element. So always make sure that you are eliminating the fragile element and create a repeatable build process. What does a repeatable build process means? For example, today I do a code check-in, tomorrow I will do another code check-in, and it goes on, right? I cannot go and do the build process again and again in a different environment. So I should always make sure that my build process is repeatable and replicable across environments and manage dependencies. Okay, the third point is very, very important. Why so? See, there could be application which uses databases or database connection it can have. There could be application where a backend and frontend will be split up. Okay, in those cases, when you deploy, the application should be deployed in such a way that all the dependencies goes to the product properly. Otherwise, you'll end up in unnecessary exceptions. And then it says create an environment for continuous improvement. So as I told you, the feedback loop will ensure that a developer or the operation guy improves himself. When he improves himself, he also makes sure that the organization gets improved. And the last and final point is infrastructure as code. Okay, what is infrastructure as code? See, what the infrastructure could be anything. It could be your database, it could be your server, it could be your cloud nodes, it could be anything that gives your environment to work on. Okay, there could be a product where hundreds of servers are brought up. Okay, how will you do building up all the hundreds of servers manually? So that is not possible, right? So treat your system like a code. There are tools that DevOps provides, or there are DevOps tools which makes programmable scripts that can actually bring up your infrastructure. For example, I can bring up 100 servers and run by running one Ansible script. Okay, that is possible. So how do we do that? Those things are all should be implemented in DevOps. And then we have to make sure that all our changes are tracked by checking into a source control. Source control can be your Git or GitHub or your Bitbucket, can even be your CVS depending on the requirement of your team. Okay, so always make sure that your changes are tracked properly. Then all your changes should be reviewed properly, should be built and then tested. Next, all these, as I said, all these things should be managed programmatically. So instead of someone doing it manually, make sure that you automate all the complete set. The only work for you should be to write a piece of code and do a checking, and everything from review, build, quality check, security check, testing should be done programmatically. That is what DevOps says. So done with 4 topics. The next we are going to move to DevOps practices. So if you have any doubts still there, just leave me a message. I'll address those doubts and then move on. So I'm passing for some 30 seconds to 1 minute. I'll wait for you people to bring me some questions. Fine, I assume there is no questions. We'll move. So DevOps practices. So what are they? The first phase is incident management system. So what is an incident management system? As a developer and guy, we are together now following the DevOps practices. We are working together. I delivered a piece of code to the customer. The customer suddenly raises a bug. Okay, that is called as incident. When it goes to the customer and the customer raises the bug, it's called as incident. Okay. In today's scenario, what happens is that only when those incidents that are very major. For example, there could be incidents where your server goes down. Only those incidents are tracked. But DevOps says that even a small instance, be it a small bug or a bigger bug, it is important for you to track. The tracking of incident allows you to have a continuous feedback and continuous improvement. Okay, this is different. Fine. And then second point says developers on call. So why do we have developers? Why should we have developers on the call? See, first point says raise an when there is a bug, it should be raise an incident, right? So someone has raised an incident. Now, whenever an incident raises, the traditional method says that it will go to the support guy. Okay, a support person will pick up the incident and will see if there is a fix available already. If there is no fix available already, he'll send it to the development team. The development team will find the guy who was checking the code. Then they will assign that bug to the development guy. Developer again will do he will report the issue. You will see that if the bug is the fix is already available. If not, you will try to fix. Imagine the time which it takes to travel. Okay, it will take almost 2-3 days in a traditional method in a small team itself. But what if I have the developer itself on the call, which means that a customer calls and says there is an incident. The developer joins the call. You can immediately go and address the issue. That is what the DevOps says. Always have your developers on the call so that all your issues are addressed in no time. Okay. Then comes your public status pages or transparent communication. Okay. We have done so many things in DevOps. We have implemented so many tools. I automated so many things. I'm doing build. I'm doing a lot of testing. I've been giving so many feedbacks. I'm just getting so many incidents and addressing the bugs. You're doing so much things, but how are you telling that you're doing all this to the outside world? And why it is necessary to tell this to outside world? See, as I told you, knowledge sharing is very, very important. Right? DevOps says that you should always share your knowledge. So when I put a public status pages, for example, I do a build every day. People should know if the build has failed or successfully run. So I should have a simple chart which says that, which should share some colors saying build has failed, mark it in red, build has successful, mark it in green. So anybody who wants to consume your product or anybody who is in your environment can easily go and see the status page, understand that something has gone wrong or something is going right. Apart from build, what else can be shown as important public status pages? For example, your server status, your DB status, your application status. All these are important metrics which should be transparently communicated, so the end user always knows that problem at at an earlier stage. Otherwise, what happens is that if you don't do this, you will end up finding it difficult to find the RCA. When you spend a lot of time in addressing the RCA, it's going to be difficult for the end user to wait for the system to come online. Okay, so it is always good to have metrics and make them public. For embedded teams, we have been talking a lot of I think the same thing is embedded teams, which means that DevOps guy and operation guy should be collaborating between each other and work together. The cloud, I think most of you must be hearing whenever the word DevOps comes, the word which comes along is that cloud. So what is a cloud? Cloud is nothing but your environment which is virtual. As today, Google, Amazon are providing cloud environments. So why do we need a cloud? The cloud provides you a very easier way to deploy a product, to manage your infrastructure, because as I said, cloud gives you the API and infrastructure as a code. So I just have to write some script and I'll bring up my application. I'll bring up n number of nodes that is required. For example, today there are 100 customers who are visiting my website. Tomorrow 100 goes 1000. I should be able to manage the load, right? How will I do that? I'll just increase my number of nodes based on the incoming user via a single command, and then automatically bring up the required number of nodes in the cloud, which is currently not possible in the traditional environment. Okay, so cloud is more important. Then a different jargon I used, and code. What is the and code? This and code is something related to car manufacturing, which Toyota uses. So what happens is that whenever there is a problem found, okay, there will be some. You can see that what is that? Stop chain, right, in all trains. Similarly, there will be chains in the production line. Okay, when manufacturer finds a defect in a car, or when manufacturer forces an issue, okay, you just pull the and cords. What happens when the and cord is pulled? The complete release is stopped. Why do you want to do this? Okay, when you stop the release, because you find an issue, you are ensuring that the issue does not travel to the customer. Okay, this is very, very important, because when you know there is an issue and if you ship the product to the customer, it's going to be very embarrassing for you because the customer is going to trash you out. So always make sure that whenever there's an issue, stop the release. Okay, that's what and code says. Then is a dependency injection. I told you, right, your product should be very loosely coupled. For example, I have a front-end application. The front-end application always goes and connects to the database, which means that I should always ensure that the connectivity to the database is up and running. Okay, when the product is deployed in the real time in the production in the customer side, I should also make sure that those environment variables that is required for my front end should be available properly. Otherwise, I'll end up in runtime problems. For example, the front end should know which database to connect. Otherwise, I'll end up saying that there is no connection between database. My application will fail, and everything will go for a toss. So always make sure that every single application that you deploy in a modular way should carry a dependency environment along with it. That is what dependency injection means. Next is your blue-green deployment. Okay, what is a blue-green deployment? In today's environment, for example, I'll give you one very good example. Okay, take your Netflix application. Okay, whenever Netflix brings an update, they won't update directly in your production. What they will do is that they will have two environments, identical environments. One will be your blue, another one will be green. Always only one will be in online state, which means that whatever you are seeing now in the Netflix web page, that is called as online environment. There will be identical environment which is called as offline environment, which will have the same content. What Netflix will do is that there's a new delivery or a new feature, they'll put the feature in the offline environment. Okay, they'll just do a testing there. Once making sure that offline environment is working fine, they'll mark the offline environment to online and online to offline. So this is just like switching. And suddenly when they find a bug in the offline environment, they can directly go to the other environment. So this is called as blue-green deployment. The one environment is called as blue, the other environment is called as green. So whichever you're marking online, that is called as green environment. So this is happening in almost all products, including your Google apps. There are so many apps right you're using. Most of the apps are doing such a thing in cloud. And next important thing is that Chaos Monkey. Again, I'll take the example of Netflix. So Netflix server is actually running in Amazon Web Service or Web Cloud. Okay. So what does Netflix do is that they have a program called as Chaos Monkey. They will have some 100 servers to serve some millions of users. What does this Chaos Monkey does is that it will go and it will bring down some servers. Okay. It is to test their product's ability to withstand the incoming users as well as to bring up new servers as soon as one goes down. Okay, all these things are to make sure that your code is very strong, your production deployment is very strong. So these practices will ensure that end to end your product is very stable and is going with minimal issues. Okay, so we have seen a lot of things. We have seen the COMS principle, we have seen the 3 ways of thinking, system thinking, and then we saw some of the important dev practices. Now we'll go to the tool structure. So as I told you, if you just go on Google for DevOps tools, you'll end up seeing some hundreds of tools. Okay, so there is no single tool which can address your complete problem. There is no single tool like that. It is our duty to go and find which tool will address our specific problems. Imagine having thousands of tools in your market, and how do you do that? You do it via continuous experimentation, right? So tools are important to automate your process and as well as address the issues then and there. So tools can be anything. You can write your own tool very well. It is possible, but DevOps says do not reinvent the wheel. So find if there is any open source tool or any enterprise tool that you wish to integrate into the product. We can very well download and integrate. So we'll see what are the different types of CI/CD and what tools fits into which environment. Okay. So okay, before that I'll tell you what are the 3 important criteria for your tools. The first thing is programmable. I'm stressing this point from the start, right? Your tool should be programmable. Once you do everything in programs, it is easy for you to deploy it at any site. So it says that it should be API driven or CLI driven, which means that having a web interface for your tool is of no use. Okay, it should be run through command line, and then is verifiable. Just because I write a tool doesn't mean that my tool works properly, right? I should have a mechanism to verify that the purpose for which I return the tool is actually achieved. Okay, that is what is called as verifiable. I should be able to verify my tool is doing what it is meant for, and then validate. Your tool should not introduce new bug in the production. Your tool should be independent of environment, and it should also work in your developer environment and environment where it is deployed. Okay, that is what is called as well-behaved. Okay, so these 3 tool criteria is very common generic thing for any tool that you write. It is not restricted to DevOps alone. This is a generic 3 steps which you should implement in your tools. So till here, any doubts? Just ping me. Otherwise, I'll move on to the next topic. So next topic is something which will introduce you to the different types of tools that is there in the market, which we can actually integrate in the DevOps pipeline. I'll tell you some of the tools, and in that some of the tools we'll be also doing the hands-on during our actual session. If you are not having any doubts, I'll just move forward. I'll wait for some 30 seconds. Fine. We'll move forward. Okay. Tools can be split into different groups. So what are these groups? So these are the minimal groups I can give you for a product to be deployed from end to end, from your source control to the customer side. Okay. The first thing is your version control. Version control is nothing but I write a piece of code, I have to deliver it in some place. Only then I will know my changes, right? Today I'm writing 100 lines of code. Tomorrow I'm updating 100 lines. So what does it mean? I have to know that how my code has changed. Not to do that, there are certain version control systems which are supposed to implement and check in our codes. Second thing is CA systems. CA system nothing but your server or your tool which runs your integration part. Okay, then is your build. The builds, as the build name build says, it is going to be your compilation of C++ files or C files or Java files. Then you'll get jar out of it, or you'll get binary out of your C files, or you'll even create exes. Okay, that is what is called as build part. Then your testing part. So after doing your build, the next step is to do a testing. Testing can be done in many phases. It could be your unit testing, where you will test your own product. It could be your integrated testing, where 10 people or 20 people will sit and test your product. It could be automation testing, where a tool will actually test your product. So in testing will be in multiple phases depending upon the need of your organization. Next, your Artifactory repository. So what is an artifact repository? So this is where you actually ship your end product. It could be your binary, it could be your jar, it could even be your small document. So Artifactory makes sure that all this goes into the Artifactory repository. Then comes your deployment. So deployment should happen by pulling your product from the artifact repository. Okay. So deployment can be done using open source tools or in-house tools, depends on your requirement. So deployment in the sense you'll actually bring up your application in a different environment. And then your monitoring. As I told you, monitoring is important for your servers, application, databases. So with this, a small group, or I would say the complete group set is combined. So we'll see what are the different tools in the each step. So version control. One of the famous thing that is given for version control is GitHub. So GitHub is going very fast. It is growing very, very faster. Even a week back, Microsoft announced Cloud IDE. I told you the importance of cloud, right? What does a Cloud IDE do? You don't have to install anything in your machine. For example, if you want to do a scene compilation, it is not necessary for you to have a GCC in your local machine. I'll just go to my web IDE, I'll write my piece of code, I'll save it in my own workspace, I'll do a compilation there itself. There's nothing required to do in your environment. So imagine the power of cloud. This is what cloud can give you. You need not have anything in your local thing. Every single dependency, every single piece of compile will be there in your cloud. So GitHub is one of the famous repositories which is owned by Microsoft now. I want you people to also explore if you are not already there. And there is another thing called as GitLab, which comes in both open source enterprise edition. There's a third-party vendor which was called as Bitbucket. So in our session, I'll take you through GitHub and Git. Okay. So this is all with version control. Next to CA systems. So the beautiful thing about CA system is that there is no actual competition in CA. Jenkins plays an important role. Jenkins is actually the master in CA system, I would say. Jenkins comes as an open source product, but there is a company called as CloudBees, which also gives you enterprise product of Jenkins, wherein they support with different types of plugins. And there are other CA products, Travis CA, Circle CA, Bamboo, which are less used. People go for that based on the benefit. So in my training, I'll be taking you through Jenkins. And then comes your build. So as I told you, right, build is nothing but creating a end product out of your source files. It could be your binary, it could be your jar file, right? So for that we use several tools. Make is used for your C binary, C compilation. Maven is used for your jar creation. Gradle again is used for your Java creation. So we have different tools to build your product. So I'll be teaching you Maven in our session. Next thing is test. I told you, right, testing can be in different phases. Unit testing can be done, your integration testing can be done, your automation testing can be done, right? So there are different tools provided for that. JUnit is for your Java unit testing. We have Selenium, a web-based testing tool, which is an automated, which can be automated through programs. RoboFramework is also an automated tool, and we also have enterprise things called as Cucumber and Source Labs. And then artifact repository. So in artifact repository, currently the major all four plays a major part in different aspects. JFrog is open source as well as enterprise edition is there for JFrog. JFrog can be based out of cloud or based out of your on-premise, and JFrog gives you complete feature like Nexus as well as your Docker registry. And Nexus also stays separately. So Nexus is mostly used for your Java-based builds. Docker Hub is for containers. AWS also provides cloud artifact management, which is owned by Amazon. And after pushing all your codes to Artifactory, the next thing is a deployment. The deployment, I think currently there is no open source for deployments. People use only enterprise editions. Urban Code is there, Rundeck is there, Deploynator is there. And for example, if you take my company, we have our in-house deployment tool. We wrote our own tool to do deployment. Because as I told you, right, it is not necessary for you to go and buy everything in the market. Okay, if you can write a tool that is very easy for you and anyone to fit in, and please go ahead and write. But also make sure that if there is an open source tool for that, do not reinvent the wheel. Fine. So next thing comes your monitoring. So we saw a lot of other items. Now the final thing is your monitoring. After deploying a product, how are you making sure that your product is up and running, or how you are monitoring the scale of your product? For that, there are several tools. We have Grafana, we have Prometheus, we have Metabase. So in our session, I'll take you through Metabase, and if time permits, I'll also teach you Grafana. So Metabase is one of the very cool open source monitoring tool, or I would say a graphing tool, with which I can actually create a chart and widgets in 15-20 minutes. Okay. So with this, I am actually coming to the end of this webinar. I have been telling you a lot of things on what is there in DevOps, what are the key values in DevOps, what are the core principles of DevOps, how do we define certain processes in our DevOps, what are the important tools that we are actually supposed to implement in DevOps. When you go for tools, how do you actually see the tools? And as a developer, how do I speak with my operation guy? And as an operation guy, how do I interact with my development team? So all these things are very important, and I covered you in horizontal scale. I will not go much deep. I have covered you as far as possible. So now the end thing is the demand for your DevOps engineers. So as I told you, right, there is a very big demand for DevOps engineers. Once if you go and say the outside market, DevOps, people go crazy. Okay, there are companies which pay people even $1,000 a month, and there are several stats which says the importance of DevOps. For example, there's a study which says that by the end of 2025, 80% of the current product will go to cloud. So see the importance of DevOps. Okay, it stresses more on going cloud. So if you know DevOps and cloud, and then automating things, I think you are very much valued. And then there is other survey which says that by 2023, there will be 200% of increase in DevOps adoption. So people are slowly moving to DevOps. There are so many startups which are deploying product directly in the cloud. One very good example is Uber. Uber actually was doing an on-premise deployment. They were struggling to get their product up and running. The main importance of DevOps is that you always ensure that your product is highly available. So Uber converted their code into small services. They deployed everything as a service in the Amazon cloud. Now Uber is actually not facing any availability issues. They're always up and running. The importance of as a DevOps engineer, I contribute in two ways. I improve the environment. I also improve myself. Fine. So with this session is complete. If you have any doubts, just ping me. Just drop a message. I'll just answer you. Otherwise, I'll take you through what Verzeo actually has there in their site. They are providing you lots of cool certifications. I'll just show you there. So I hope you are able to see my browser. So if you see Verzeo is providing a lot of internship programs. One of the program is DevOps. So you can visit Verzeo site, check for the course that you are willing to take up, and you can very well register. You can very well, there are the contact numbers given. You can connect with them. So I'm getting a ping. Please, yeah, please. So if you're asking any doubts, just let me know. If you're having any doubts, let me know. I'll wait for some another 5-10 minutes. I'll ensure that all the doubts are clarified, because it's very important for you people to understand the need of DevOps in the current trend. Only when you understand the need of DevOps, it will be good for you to implement that in your career and then go forward. So today I just showed you what theoretical view of DevOps. When you attend the course, it's going to be very fun. You'll have lots of hands-on. You'll have lots of scripting. It's going to be very fun. Yes, Sagil. This is the certification program provided by Verzeo. You'll be given a certification. There is a class arranged for this. I think 2 to 3 months. So those details you can get it from Verzeo site. This is just a demo webinar. Actual session will start from June. Any more queries, guys? I think we are in, if there is no queries, I think we can close off. Okay, there is a message again. If people are having some, there is the Amazon Web Service webinar tomorrow. Feel free to attend. Thank you. So, thank you guys. Thank you for listening to me very patiently. I hope this somewhere I was able to trigger you the importance of DevOps. Good luck for you people. Thank you.